Today we are going to take a look at vectors. So this is a new topic for most people. So a couple things we're going to figure out today what a vector is. We're going to write them in component and unit form. We're going to learn how to add and subtract vectors, how to calculate the vectors, and to multiply a vector by a scalar. So the first thing, what is a vector? Well, there's a difference between a scalar and a vector. A scalar here is something like temperature, it's 32 degrees outside, or distance, he ran 5 miles, or he's going 52 miles per hour. Whereas a vector, it's more like displacement and velocity. So you're adding something else to here. A vector is something that has magnitude, which is the size of it, and direction. So when you're talking about, he's going 52 miles per hour in a northwestern direction, we're adding that directional piece there. So if we were asked to sketch something, a vector, it's 50 newtons, so we're dealing with some physics here, on a bearing of 120. So I'm going to dash in this horizontal, and it's going 120 degrees. So a vector is usually drawn with an arrow here. So this is 120 degrees. And that magnitude, we would say, is 50 newtons. So now a lot of times you'll see them with just written with arrows. So the length of the arrow is the magnitude, and the arrowhead indicates the direction. So this one doesn't have an arrow. So let's say we were to put an arrow on here. The way you would see this written is you'd see vector A to B with a little arrow above it. And then it's written in what's called component form with your x component and your y. So let's see, 1, 2, 3. So to get from A to B, you go over 3, 1, 2, 3, 4, and up 4. So it would be written, sometimes you see it in brackets, other times parentheses, 3, 4. Or sometimes you'll also see it with these little arrows and it'll be 3 comma 4. So it's not a coordinate, it has these arrows here on either side. You'll often see it just with a lowercase bold letter too. You could say vector A, and this would be in bold, and you'd say the same thing. It's 3, 4. It goes over 3, up 4. Now, you really have to watch the direction here, because if this one, let's say the arrow was down here, and I would have said you're going from B to A, that changes things slightly. Well, let's see, from B to A, we're going down 4 and backwards 3, so our x component would be -3, -4. So you're always going, sometimes you see it from tip to tail. You'll always call it tip to tail here. This is your tip, that's your tail. But you always have to go from start to finish. Where are those directions telling you to go? So if we were asked to find the magnitude here, what does this vector tell us? Well, it tells us we go over 3 and up 4. So there's our magnitude. Well, what could we do to find that length? Well, this is a right triangle. So 3 squared plus 4 squared equals c squared. 25 equals c squared, so c is 5. So our magnitude is 5. Now the notation. You'll see it in as magnitude. Oftentimes you'll see it with absolute value signs, like find the magnitude of AB, or if it's written with that bold letter, find the magnitude of A. Oh no, and workspace just closed. Let's see if we can get it back up here again. Let's see. Uh-oh, where did it go here? Let's try that. We'll try closing it again. Sorry, guys. And now we'll see if it comes up so we can keep on going here. But that is how you know size and magnitude. Magnitude's that length, and size is like the length of it. Excuse me, and direction is telling you those x and y components. All right, so let's see here. We have a parallelogram. So opposite sides are parallel, P, Q, R, and S. And now these should be in bold because it's standing for a vector. So P to Q is A, Q to R is B, and so I'm going to put arrows. We're going from P to Q, we're going from Q to R. and express for the write in vectors for the following: Q to P. Well, how do we get from Q to P? Well, that's going backwards, so we'd say it's the opposite of vector A. R to Q, well, B is going this way, so we're going the opposite direction of vector B. S to R, well, we're going S to R, well, that's the same direction, so it's a parallelogram, so it's the same as vector A. And then S to P, going this direction, well, that would be the opposite direction of vector B. So when you're constructing these, tip to tail, you'll never have an arrow facing an arrow. You'll always have your start to the direction it's going. So you won't find those two arrows facing each other. Now, if we were to add these, so for example, if we were to add 3, 2 plus a vector 4, 5, what's it saying is we have a vector, we go over 3 and up 2. And then what happens is we take our vector and we go over 4 and up 5. So how do we really get from one to the next? Well, total we go over 7, right? We go over 3 and over 4, and then up 2 and up 5. So we go up 7. So we add our horizontals and our verticals there. So when you're adding these, same with subtracting, you just subtract them then. So we have Q, 1, 4, minus our P, 3, negative 2. So what does that equal? Well, 1 minus 3 is negative 2. And then we have 4 minus negative 2. Well, minus and negative is a positive. So we'd have negative 2 and 6. Now this next one we're doing 3 right in a row, but we'll do the same thing. 3, negative 2, minus 1, 4, minus negative 2, negative 5. So if we subtract these, 3 minus 1 is 2, minus negative 2. So we have 3 minus 1 minus negative 2. And then the vertical component, negative 2 minus 4 minus negative 5. So let's see, this would be negative 2, so this is plus. So that's a movement of 4. Negative 2 minus 4 is negative 6, plus 5 is negative 1. And then we have Q plus R, 1, 4, plus negative 2, negative 5. Well, this is 1 plus negative 2 is negative 1. 4 plus negative 5 is negative 1. 3Q, this is what we call multiplying by a scalar here. So all we're doing is taking 3 times Q, we multiply them each times 3. It's like we're extending that length 3 times. So we go 1, 4, 1, 4, 1, 4. So total we're going over 3 and up 12. And P minus 2R, 3, negative 2, minus 2, negative 2, negative 5. So one thing we can do is multiply that scalar first. So this is 3, negative 2 minus, if we just distribute the 2, we'd have negative 4, negative 10. You could distribute the negative and make it plus that as well. And if we subtract these, 3 minus negative 4, so plus, we got 7, negative 2 minus negative 10, so that's plus, so we would have a 8. Now we're asked to find the magnitude. Well, this one, what does P do? It goes over 3 and down 2. So our magnitude, 3 squared plus negative 2 squared, is our hypotenuse. So let's see, 3, 9 plus 4 is 14. So it's the square root of 14. Well, what does R do? It goes backwards 2 and down 5. So we have negative 2 squared plus negative 5 squared. So 25 plus 4, so 29. So it would be the square root of 29. And then we got Q minus R. So first we have to subtract these. Oops, I don't know why I wrote a fraction there. 1, 4 minus negative 2, negative 5. So this equals 1 minus negative 2, so we have 3. 4 minus negative 5 would be 9. So this one over 3 and up 9. So we have 3 squared plus 9 squared equals c squared. 9 plus 81. So we have 90. So we have the square root of 90. So now we're asked to find these. Find P, Q, and the magnitude. So we're going from P to Q. So we have negative 1, 2, and it ends at 3, 1. Well, what's happening here? Negative 1 to 3. So our vector, it's going up 4, and then our y value, 2 to 1, down 1. So that would be vector PQ. And then that magnitude, that absolute value, so we would do absolute value symbols there, 4 squared plus negative 1 squared. So that's 17, so it would be the square root of 17. Well, how would this change if you wanted to find vector QR? You're just going the other way, so you're going 3, 1 to the coordinate negative 1, 2. So our vector here, 3 to negative 1, we're going down 4, 1 to 2, and up 1. So that would be our vector going the other way, and then that magnitude would be the exact same. So we have to use parallelograms, use vectors to show this is a parallelogram. 2, 1, 2, 3, 4, 5. So we have A, B, C, and D. Okay, well let's see, vector AB, what would that be? Well, A to B, negative 2 to 3 would be 5, 5 to 1, it's going down 4. Well, that's got to be DC, would have to be that same vector, it needs to be the exact same, so D to C, negative 3 to 2, up 5, 3 to negative 1 is down 4. Then we could check the magnitude, 5 squared, well we know those are going to be the exact same magnitude, negative 4 squared. So they both have a magnitude of 25 plus 16 of the square root of 41. So they have the same direction and magnitude, so those are the same. And then let's check A to D would have to be the same as B to C. So A to D, negative 2 to negative 3 is going down 1. 5 to 3 is going down 2. B to C, 3 to 2 is going down 1. 1 to negative 1 is going down 2. And then again, that magnitude is the exact same. So we'd have 4, 5, so our magnitude is root 5. So vectors are parallel, then one is a scalar multiple of each other. So if you had a 12, 4 and 6, 2, these are, the magnitudes are different, but they're going to be parallel. For example, this one is going over 12 and up, that's totally out of, over 12 and up 6 would be this one, whereas this one it's just going over 4 and up 2. So it has that same slope there. A unit vector. These are pretty easy. A unit vector is just saying it has length 1. So I is going not over 0 and up 1, 0, 1. So 0 and over 1. So if you needed to write this in vector form, you're using these i's and j's, it's pretty easy. Your x, there'd be negative 3 i's, because it's like we'd go back 1, and back 1. All of these are length 1. And then we'd go up 4, so plus 4j. And that's in unit vector form. So this in component vector form, this is our x, and this is our y. So we'd have 2, negative 5.